In this video I'm looking at the solution to question 10 of the January 2011 Edexcel FP1 paper. The topic of the question is coordinate systems. So the question starts off by telling us that a point on a rectangular hyperbola with equation xy equals 36 is given by p is 6t 6 over t. In the first part of the question we're asked to show that the tangent at this point to the hyperbola is given by the equation y equals -1 over t squared x plus 12 over t. And then in the second part of the equation asked to find the points where a and b such that two of these tangents meet together at a point given as -9, 12. So looking at the first part of this to start off with, well, the standard sort of method to find tangent is first of all we must find the derivative. So if xy is equal to 36, then y is equal to 36x to the -1, and therefore the derivative dy by dx is equal to -36 x to the power -2. At x is equal to 6t, this gives us a value of dy by dx equal to -36 divided by 6t all squared, or in other words it's equal to -1 over t squared. The equation of the tangent then is found by substituting the values we know into the standard equation for a straight line. So it's y minus the y value 6 over t is equal to the gradient -1 over t squared multiplied by x minus the x value that we know, which is 6t. Multiplying out the right hand side gives us y minus 6 over t is equal to -x over t squared and then plus 6 over t. Then adding 6 over t to both sides gives the equation we've been asked to find. Y is equal to -x over t squared plus 12 over t. The marking for that was a method mark for an attempt at differentiation, a method mark for substituting the value x into the derivative that's found, and then an answer mark for getting -1 over t squared. In the second part of this we get a method mark for correctly using the equation of a straight line to find the tangent, and then an A mark at the end for getting the correct answer. This is what's called a correct solution only. You're told the answer in the question, and therefore you must make sure that your working is entirely correct to get that final A mark. In the second part of the question, then we're going to carry on and use the tangent equation we found to find the two specific tangents which meet at the point x is equal to -9 and y is equal to 12. So using those values and substituting them into this equation gives us 12 is equal to -1 over t squared multiplied by 9. Beg your pardon, multiplied by -9 plus 12 over t. Multiplying throughout that by t squared gives 12t squared is equal to 9 plus 12t, and then writing as a quadratic equal to 0, 12t squared minus 12t minus 9 is equal to 0. We can divide throughout that by 3. There's a factor of 3, so dividing gives us 4t squared minus 4t minus 3 is equal to 0. And this factorizes 2t minus 3 multiplied by 2t plus 1 is equal to 0. So we've got two values of t. T is equal to 3 over 2 or negative 1/2. T is equal to 3 over 2. Substituting that gives us the first point. So simply substituting that into our standard parametric values that were given at the start, it was 6 multiplied by t, so 6 multiplied by 3 over 2, and then the y value is 6 over t, so 6 over 3 over 2, and that is equal to 9,4. And substituting t equal to negative 1/2 in a similar way gives us b is equal to negative 3, negative 12. The marking for that, 7 marks in total. The first was a method mark, M1, for substituting into the tangent equation, a method mark for multiplying by the t squared, and then a final third method mark here for getting the factorizing the resulting quadratic. An A mark, answer mark, for working out the values of t from that, and then method mark for substituting, and then finally two answer marks, A1 and A1, for getting the points A and B. So a total there of 7 marks. Well, that completes that question. Further questions for this module and indeed for other modules can be found at www.furthermaths.org.uk.